Okay, so 10.4, we're dealing with application, which is that dreaded word everybody likes to hear, and that's word problems. Really, word problems aren't all that bad. Let me see if I can get rid of that. There we go. Word problems really aren't all that bad in this section. We're going to talk about kind of how to work through them, how to identify what type of problem they are, and then we're just going to work a few examples. Now, remember, I've taught you in now 3 videos on how to work on systems of linear equations. So by graphing, by substitution, and by addition. Now we're going to use any and all of these for working this section. You're going to get to pick the one you like best. Now traditionally I suggest substitution or addition just because you may not always get an even solid answer. You may get a decimal or you may get a fraction. And remember, substitution and addition, that's where they're really good. So we're going to work a few problems here. Now I'm not going to be writing a bunch of these out here. Instead, what I've done is I've pulled up pause, and I'm going to let you have some time to read and write down the question as we work through them, but I'm not going to write it down. I'm just going to do the translation. So here we go. So the first question is what we're going to call the age question. All the age questions are going to look very similar in this questions or in this section. So here we go. So it says Gloria is. Now is means equal. So Gloria is 22 years older than her brother Ed. Well, now let's pause for a second here, and let's jump back and let's try to translate that. So we know that Gloria, let's call that the variable g. So Gloria is, well, we know that is means equal, so Gloria is, and I believe that said 22 years older. Yep, 22 years older than her brother Ed. Well, let's think about that for a second. So that means that Gloria, her age is Ed's age plus 22, right? So that's Gloria's age is equal to Ed's age plus 22 years. Not too bad. That's not too bad. So now let's go to the next one. Now, 4 years from now, I want you to remember that, but we're not going to deal with it just yet. Gloria, okay, we've already said that her age is going to be g. Will be, well, that's the future tense of is, so that's going to be an equal again. Gloria will be twice as old as Ed. Well, we know that the word twice means multiply by 2. So that can be translated as Gloria will be 2 times Ed. 2 times Ed's age, specifically. Does that make sense? So, again, we ignored the fact that it's going to be 4 years from now. We're going to deal with that. But Gloria will be twice as old as Ed. I'm going to pause here for a second. I'm going to let you write down that in case you want to. Okay, so you should have written that down, and now we can go about working the problem. Okay, well, let's take a look here. So we get the idea here of, do we want to use graphing, substitution, addition? What do we want to use? Well, to me, this just screams substitution because I've already solved for my g. I've already solved for that variable. Well, that means if I know that g is equal to 2e, it means I can take 2e and I can simply replace g with that, right? If you're struggling with substitution, go back to 10.2 and work through some questions. That should help you pretty significantly. Okay, so 2e will go in for g, so we get 2e is equal to e plus 22. Now all we need to do is solve. Well, of course, we solve a linear equation like this by subtracting our e from both sides. Well, 2e minus e is just going to leave me with e. So we know that e is equal to 22. And specifically, that is, I believe it was Ed's age. But now that we know Ed's age, we need to find out what Gloria's age is. Well, that's not bad. We know what E is, so we're going to plug that in for E. That will give me that Gloria is equal to, we know that E is 22, so we're just going to plug that in. 22 plus 22. Well, that means that Gloria is equal to 44. Now, we've introduced a little bit of error in this problem. Remember, we talked about the fact that this is 4 years from now. Well, we've indicated 4 years, but we never adjusted for that. We need to adjust for that now. So, this is Ed's age in 4 years. This is Gloria's age in 4 years. So to make that correction, all we need to do is subtract 4 years from each of their ages. Well, 22 minus 4 is equal to 18. So Ed is currently 18. And Gloria is 40 years old. Okay, that is an age-style question. This is our final answer. But we should be able to see here that anything, if there's a relationship between them, can be written as a system of linear equations. And while this could be written as a Cartesian point, it also gives us the correlation between those two ages. Okay, so for our second example, we're going to talk about money. For many money-style questions, specifically in this section, we're going to deal with two types. And the two types we're going to deal with are going to ask two questions. The first question is how many? That's going to create the first equation of our linear equations. And the second is going to be how much? Well, we're dealing with money, so we need to deal with how much money are we going to be dealing with. Okay, so let's jump over to Hawks and let's look at this question. Okay, so Danielle has some dimes and quarters. Okay, if she has 30 coins worth a total of $5.10, how many of each type of coin does she have? I'm going to pause this here. And you pause your video as well. Go ahead and write this question down, and then we'll come back and work it. Okay, so hopefully you have paused the video. You've got all this written down. So let's work this out. So Danielle has some dimes and quarters. Notice that we need to use D and Q. D for dimes, of course, and Q for quarters. The first question we're going to ask is how many? Well, how many coins does she have? We know she has dimes and quarters, but we also know that she has 30 coins. So we know now that our number of dimes plus our number of quarters are going to equal 30. Well, that answers our how many question. But now we need to know how much. Well, let's jump back over to our question here. So it says she has 30 coins, and those coins are worth a total of $5.10. So that's going to answer our how much question. Well, our number of dimes times what it's worth, so that's 0.1, right, because that's 10 cents. It's a tenth of a dollar. So my 0.1 dimes plus, well, a quarter is worth 0.25, right, 25 cents. 0.25 times my number of quarters is going to equal $5.10. We can just enter that as 5.1. Oh, well, that's not too bad. What I want to do now, I want to get rid of these decimals. I want to make it one solid number. And I do that by counting the number of decimal places. There's 2 decimal places. And so I'm going to multiply that by 100. Now what that's going to do, multiplying any number by 100, is going to move the decimal place 2 places over. So what that's going to do is it's going to give me a solid number. Multiplying by 100 here is going to move my decimal place 2 over. Multiplying here, 2 over. And then multiplying here, we'll move 2 over, which I have to add a 0, of course. So that's going to give me that D plus Q is equal to 30. And it's going to give me that D, this is plus 25Q, is equal to 510. Okay, well, we can work with this. So, I've made a mistake here. So, a dime is not worth 100. A dime is worth a tenth. So, this is actually 0.1. Go in and make a correction to your notes there. So, what this is going to make this become is actually 10, because when I move it over, I'm going to have to add a 0. Sorry about that. Okay, well, here is my system of linear equations that I can actually work with. Here, I'm really going to suggest that we use addition. I think addition is a good one to use here. Remember, I need the same coefficient. but I need different signs. So let's get rid of our D's and let's multiply by a negative 10. Multiplying this in, that's going to give me negative 10D minus 10Q is equal to negative 300. Well, we have 10D plus 25Q is equal to 510. Well, addition means I add my lines together. My D's, of course, are going to cancel. And that's going to leave me with 15Q, or 15 quarters. Okay. Well, now I need to combine these terms. So I'll just come out here to the side. So this is 510 minus 300. Gives me 0, 1. That gives me 210. Positive, of course, because my larger number is positive. Now, what I need to do is I need to solve for Q. Solving for Q isn't too bad. That is going to be division by 15. So my number of quarters is going to equal 210 divided by 15. That's going to give me 14. So that divides evenly. Well, this tells me that my number of quarters is equal to 14. Well, that's good, because I'm wanting to know how many of each I've got. Well, I know my numbers of quarters is 14, but I also know that the number of dimes plus the number of quarters are equal to 30. So all I have to do is plug this in to my number of quarters. So dimes plus 14 is equal to 30. Subtract 14. Subtract 14 gives me that dimes are equal to, well, this gives me 6 will get me to 20, and 10 will get me to 30, so that will get me to 16. So now I know that I have 16 dimes and I have 14 quarters. That answers my two questions, how much and how many. And I know that if I have a number of dimes plus a number of quarters equal to 30, and those coins are equal to 510, that I can solve that for the number of dimes and quarters that I've got. And that will work for any money question throughout this section.